Take a close look at this gently dilating pupil. At this very moment, particles of light are relentlessly bombarding your retina, silently converting into tiny electrical impulses that travel along your nervous system. But what you are seeing, that has never been the complete reality. It is merely a tiny, filtered slice, the small portion that your brain has agreed to process so that you can perceive the world around you in the most normal way possible. We are inherently trapped inside a miraculous biological machine, an entity pre-programmed to prioritize survival, not to seek the absolute truths of the vast universe. I want you to relax your body and hold your breath for a moment as our camera begins to dive deep through the optic nerve, entering the intricate labyrinth of neurons. Here, in the silent darkness of the skull, the illusion of your scale begins to form. You've always been certain that you understand what is large and what is small, but this very confidence is the greatest deception of our minds. The human brain is, in fact, a tool forged on the vast savannas of primeval Africa. Evolution set a very simple and pragmatic task for our ancestors: find water, detect a predator hiding in the grass, or throw a stone with precision at a target. Our neurobiology was therefore calibrated for a horizon only about 5 kilometers away. Everything beyond this short distance, to the subconscious, becomes merely an abstract concept, a flat and soulless backdrop on the stage of an immense theater. We are excellent at judging the distance of a pounce from a leopard, yet completely blind to the black abyss between the stars. We live in a place called the middle world, a narrow band of perception situated between the quantum chaos of subatomic particles and the grand majesty of gravity from colossal galaxies. The camera now flies higher, escaping the biological tissue to enter the cold atmosphere of a metropolis at night. The brilliant lights of the highways, the soaring skyscrapers, the faint glows from tiny windows, all of it is a monument to our anthropocentrism. We have built a civilization that fits our stature, that fits the length of our stride. Our most basic unit of measurement is this planet. The Earth's diameter is 12,742 kilometers. Please remember this number well. 12,742. To you, this is probably an enormous number, requiring a tiring flight of many hours. But on the grand scale we will discuss today, the Earth doesn't even count as a single pixel. It's like a negligible rounding error. Ascending into the stratosphere, we leave the bustling noise of the city far below. Here, in the absolute silence, where the sky begins to turn a deep black, mathematics truly begins to speak. To perceive our true position, we will be forced to shatter our long-held, familiar perception of time. Let's conduct a fascinating thought experiment, an idea once proposed by the astronomer Carl Sagan. But this time, we'll update it with the latest data from the year 2025. Imagine we could compress the entire lengthy history of the universe from its creation until now, that's 13.8 billion years, into a single calendar year. On this scale, the echo of the Big Bang would ring out at the very first, 2nd of January 1st, and our present moment would be the stroke of midnight on December 31st. In this magical cosmic calendar, our Milky Way galaxy only formed in May. The solar system and our beloved Earth didn't appear until early September. The first life forms left the oceans to come ashore in late December. The dinosaurs dominated this planet from December 25th to the 30th. And now, prepare for the most terrifying part. The entire history of humanity, from the first cave paintings to the launch of the James Webb Telescope, is all contained within the final 14 seconds of the year. A mere 14 seconds. All the brutal wars, the religions, the mighty empires, and even your own burning personal ambitions, all of it is just a fleeting flash in the final report before the clock chimes in the new year. I see the data on the screen, constantly changing. We are crossing the Kármán line, the fragile, conventional boundary of space. Here, limited human intuition must finally surrender, giving way completely to the cold language of the logarithmic scale. Sophisticated instruments are recording radiation that has traveled for billions of light years to reach us. But our tiny brains constantly resist these unimaginable numbers. It cannot comprehend what 10 to the power of 24 is, just as you cannot imagine a color that lies outside the 7-color rainbow spectrum. We are suffering from a cognitive blindness, like trying to measure the entire vast ocean with a tiny teaspoon. And it is right here, in this very orbit, that a psychological collapse will occur, completely changing everything inside you. Astronauts often call this the overview effect. This is not merely a beautiful view through a spacecraft window. It is a fundamental shift in consciousness, something that has been clearly documented by psychologists at NASA and Roscosmos. When a person sees the entire Earth with their own eyes, silently suspended in the absolute emptiness of the void, all political borders are erased, and human conflicts suddenly become ridiculously absurd. But behind that overwhelming excitement lies an existential terror. You suddenly realize that the thin blue line of the atmosphere is the only thing separating everything you love from the deadly cold and ruthless vacuum. This is not a fortress planet. It is just a fragile oasis dangling on the edge of an abyss. Modern astrophysics is truly cruel to our human ego. Data from the Gaia mission, which maps billions of stars, along with the deep field images from the Webb telescope, are all whispering one thing to us. We are not at the center of anything. We are not even in the suburbs of somewhere truly important. We are just on a very ordinary rock, orbiting an unremarkable yellow dwarf star in a quiet spiral arm of a galaxy, which itself is just one of hundreds of billions of other galaxies out there. Statistically, our existence is so improbable that it could be considered just a random fluctuation of matter. But scale isn't just a story about distance. It's also a great time machine. When we look into the deep universe, we are actually looking back into the past. Light always needs time to reach us. The moon you are seeing is the image from 1 second ago. The sun is from 8 minutes ago. And the faint smudges of light that telescopes record, those are the ghosts of galaxies from a time before the Earth was even born. We are living in a bubble of the present, yet we are surrounded by countless layers of the deep past. And a paradox we must unravel is this: the farther out we look, the younger the universe appears to us. I want you to temporarily forget those dry solar system models in textbooks, where the planets are neatly arranged in a cramped row. That is just a convenient lie for the sake of printing. Our reality is composed mostly of emptiness. If we were to shrink the sun down to the size of a grapefruit, the Earth would be just a tiny poppy seed located 10 meters away, and the nearest star to us, a similar grapefruit, would be thousands of kilometers away. Between them, there is absolutely nothing, a chilling emptiness, echoing what we call a vacuum. We are accustomed to thinking that matter is the standard of existence and empty space is the exception. But physics proves the opposite. 99.9% of an atom's volume is empty space. 99% of the entire universe's volume is also empty space. Matter is actually an extremely rare anomaly, like a thin layer of dust suspended in infinite space. You, me, this screen, and the Earth itself, we are all just a negligible error in the grand equation of emptiness. And right now, we will begin the journey to see the true scale of this tiny error. Are you truly ready to move beyond your limited biological perceptions, to leave the cozy cradle of Earth and face numbers that can shatter all reason? In the sections to follow, we will journey from our familiar orbit to the very event horizon, where even the concept of space vanishes. We will witness the fabric of reality, a structure that inspires terror in even the greatest of minds. Take one last look at Earth. It seems huge, solid, and eternal to you. But that is merely an illusion of perspective. The moment we begin to pull away, it will disappear faster than the blink of an eye. We begin the countdown. The issue is no longer where we are. The main question that will haunt us to the very end is, if the universe is so terrifyingly vast and ancient, then why is it so silent? Where is everybody? Don't take your eyes off that tiny blue dot. That is Earth. It may seem like home to you now, but as our camera pulls back, something frightening begins to happen. The planet that once filled your entire frame is now shrinking rapidly. First, it's the size of a coin, then a tiny pinhead, and finally, it vanishes completely into the night. The immense abyss surrounding us is not an artistic device. It is the truest form of the solar system. We are forced to commit this act of mental violence against our familiar picture of the world. The diagrams you often see in classrooms, where Jupiter is right next to Mars, are in fact a criminally distorted representation of scale. If textbook publishers were to draw the planets to their correct proportional distances, they would need a sheet of paper several kilometers long. Reality is not a cramped apartment, but a desolate desert where neighbors can never see each other. Let's conduct an experiment to feel this isolation in the most physical way. Suppose we shrink the Earth down to the size of a standard tennis ball. On this scale, the moon would be just a ping-pong ball located about 2 meters away from us. So what about Mars? In this miniature model, you would have to walk nearly a kilometer to get there. And throughout that entire journey, you would encounter nothing but a sterile and absolute emptiness. On this very same scale, our Sun would be a giant sphere with a diameter of up to 7.5 meters. If Earth, that tennis ball, were at the entrance of the Kremlin in Moscow, the Sun would be blazing all the way out in the Sadovoi Ring area. Between them is a cold vacuum, with no air, no warmth, and no sound. We are living on a pitifully small island of matter, isolated by terrifying distances that the human brain simply refuses to accept. But the scale of distance is only half the problem. The other half is speed. In the universe, there is an absolute physical limit we call the speed of light. In a vacuum, that speed is 299,792,458 meters per second. That number sounds enormous, doesn't it? On Earth, it means instantaneousness with just a snap of your fingers. The light turns on immediately. However, here, in the black abyss of the cosmos, light becomes painfully and unbearably slow. It crawls like an ancient snail. Look at the sun again. The light touching your eyes right now actually left the star's surface 8 minutes and 20 seconds ago. You are not seeing a real star, but merely its ghost from the past. If the sun were to suddenly go out right now, we would continue to live in blissful ignorance for exactly 8 more minutes, still enjoying the warmth of a star that no longer exists. The situation becomes even more dramatic as we look toward the farther boundaries of our home. It takes light about 5.5 hours to travel from the sun to the orbit of Pluto. For a particle of light, the fastest thing in the entire universe, that is truly a long and grueling marathon. Imagine a conversation with someone settling on Pluto. You say, "Hello," and your voice has to fly through the immense darkness for 5.5 hours. Their reply would take a similar amount of time to return. 11 hours of absolute silence, just for a brief greeting. This bitter truth has turned the universe into a cosmic prison. We are locked in a cage whose bars are forged from the most fundamental laws of physics. Even if humanity reaches the pinnacle of technology and builds ships that travel at the speed of light, we will forever remain pathetic hostages of time. Interplanetary travel is not the exciting adventure we often dream of. Rather, it is a long exile that can consume years, or even a person's entire lifetime. We humans have a creation, a living testament to our powerlessness against the grand scale of the universe. Clearer than any dry mathematical equation. It is the Voyager 1 probe, launched in 1977. To this day, it has become the fastest man-made object ever to leave Earth. It is currently hurtling into the distant void, moving away from the Sun at a speed of up to 17 kilometers per second. Just imagine, this speed is 20 times faster than that of a rifle bullet. Voyager 1 has journeyed relentlessly for nearly half a century. Its engine continues to operate silently, and streams of data are still persistently transmitted home. It has traveled billions of kilometers, but if we place its journey on a realistic star map, the result is truly pathetic. After 50 years of continuous flight at supersonic speeds, it has only traveled less than a single light day. By galactic standards, Voyager 1 hasn't even really stepped across the threshold of our home. It's still wiping its feet on the welcome mat right outside the front door. Are you starting to feel the horror of this scale? 17 kilometers per second is practically nothing. Even the speed of light is barely a drop in the ocean. Our solar system, which once appeared as a colossal empire in the human mind, is in reality just a tiny speck of light, lost in an endless, dark forest. And the scariest thing is, we haven't even reached its true boundary yet. We're still just splashing in the shallows near the shore. The Sun's gravitational influence doesn't end at Pluto. It extends much farther than that, deep into the eternally frozen region known as the Oort cloud. This is a gigantic sphere containing trillions of icy fragments surrounding us from all sides. To reach the inner boundary of this cloud, Voyager will need another 300 years, and to actually cross it, it will need 30,000 years. Take a moment of silence to reflect on this number. 30,000 years of continuous flight at the maximum speed that humanity's most advanced technology can achieve. And all that effort is just to leave the vicinity of our own star. We are truly trapped here. Space is a perfect isolation wall. It protects civilizations from contacting each other more securely than any fortified prison wall on Earth. And now, we will leave this safe zone for good. The Sun is now just an ordinary bright star, like any other, on the black velvet tapestry of the cosmos. The temperature outside has dropped profoundly to near absolute zero. We are entering the interstellar medium, an empty and frigid ocean, where distance is no longer measured in hours of flight, but in long years of travel at the speed of light. And it is there, in that pitch-black darkness, that a discovery awaits that will make you feel more alone than ever before. Now, try to look back. What was not long ago a blazing disk, giving life to all species, has now turned into a cold, sharp, and tiny point of light. In this remote periphery, the sun still shines, but it no longer has the strength to provide warmth. We have officially crossed an invisible boundary, where the last of the solar winds must yield and give way to the immense pressure of the interstellar medium. Around us now is only absolute silence, and the temperature is just a few degrees above absolute zero. This is not merely coldness, but the complete absence of all energy. Your eyes will find no anchor here. Contrary to popular cinematic portrayals, you will not see dense asteroid belts where a spaceship must skillfully maneuver to avoid collision. Mật độ vật chất ở khu vực này thấp đến không đáng kể, thấp đến mức khoảng không mang lại cảm giác vô trùng tuyệt đối. Nhưng đây là một sự trống rỗng đầy lừa dối. Chúng ta đang tiến vào đám mây Oort, một kho chứa hình cầu khổng lồ chứa hàng nghìn tỷ thiên thể băng giá, bị đóng băng trong sự chờ đợi vĩnh cửu, một cú hích hấp dẫn từ hư không. Chính tại đây ẩn chứa quan niệm sai lầm lớn nhất của nhân loại về kích thước ngôi nhà của mình. Chúng ta quen nhìn hệ mặt trời như một cái đĩa phẳng, với các quỹ đạo hành tinh được sắp xếp gọn gàng trên một mặt phẳng. Nhưng miền hấp dẫn thực sự của mặt trời là một hình cầu, và hình cầu này có kích thước lớn đến đáng sợ. Đám mây Oort không phải là một lớp vỏ mỏng manh, mà là một lớp bao dày, đặc, trải dài sâu vào vực thẳm. Hãy cùng xem xét các con số để có cảm nhận tốt hơn về quy mô này. Các nhà thiên văn học thường sử dụng một phép đo gọi là đơn vị thiên văn. Đó là khoảng cách trung bình từ trái đất đến mặt trời, tương đương 150 triệu km. Sao Diêm Vương, hành tinh mà chúng ta từng coi là ria xa nhất, thực ra chỉ cách chúng ta 40 đơn vị thiên văn. Tuy nhiên, ranh giới bên ngoài của đám mây Oort trải dài đến tận 100.000 đơn vị thiên văn. Con số này, 100.000, thực sự khó để chúng ta hình dung bằng km thông thường. Vì vậy, hãy chuyển nó sang ngôn ngữ của ánh sáng. Ranh giới của miền mặt trời của chúng ta cách tâm của nó khoảng 1,55 năm ánh sáng. Hãy thử nghĩ xem, lực hấp dẫn từ ngôi sao của chúng ta có thể giữ các vật thể ở một khoảng cách xa đến mức ánh sáng phải mất 18 tháng mới có thể di chuyển đến đó. Đây là kích thước thực sự của hệ thống của chúng ta. Một quả cầu khổng lồ có đường kính lên tới 3 năm ánh sáng. Nhưng điều gì đang chờ đợi bên ngoài quả cầu vĩ đại này? Chúng ta đang tiến đến một khái niệm khiến các nhà vật lý thiên văn kinh hoàng hơn cả lỗ đen. Sự cô lập tuyệt đối giữa các vì sao. Chúng ta luôn có cảm giác rằng dải ngân hà là một nơi đông đúc với nhiều ngôi sao, rằng chúng ta là một phần của một cộng đồng nhộn nhịp. Nhưng thực tế phũ phàng cho thấy các ngôi sao chỉ là những ngoại lệ cực kỳ hiếm hoi trong một đại dương hoàn toàn trống rỗng. Chúng ta không sống trong một khu rừng rậm rạp. Chúng ta sống trong một sa mạc hoang vắng, nơi cái cây gần nhất nằm ở phía bên kia của đường chân trời. Người hàng xóm gần nhất của chúng ta là ngôi sao lùn đỏ, tên là Proxima Centauri. Khoảng cách đến nó là 4,24 năm ánh sáng. Con số này nghe có vẻ giống như một thống kê khô khan cho đến khi bạn thử chuyển nó sang một quy mô quen thuộc hơn với trái đất. Để thực sự hiểu được sự cô đơn của nhân loại, chúng ta cần thu nhỏ vũ trụ xuống một kích thước mà bộ não nhỏ bé của chúng ta có thể xử lý được. Trong thí nghiệm tưởng tượng này, chúng ta sẽ thu nhỏ mặt trời thực tế có đường kính hơn 1 triệu km xuống kích thước của một quả bưởi lớn, đường kính khoảng 14 cm. Hãy đặt quả bưởi này ngay tại trung tâm của Washington, D.C., chẳng hạn như trên National Mall. Trái đất của chúng ta bây giờ sẽ chỉ là một hạt cát nhỏ, bằng đầu kim gút, lặng lẽ quay quanh quả bưởi ở khoảng cách 15 mét, tức là khoảng 50 feet, đâu đó gần đài tưởng niệm Washington. Và bây giờ là câu hỏi quan trọng nhất. Trong mô hình này, người hàng xóm sao gần nhất của chúng ta, Proxima Centauri, sẽ nằm ở đâu? Ở ngoài ODC ư? Hay đâu đó ở Virginia? Câu trả lời là không. Quả bưởi gần nhất sẽ ở tận Los Angeles, có lẽ là trên đại lộ danh vọng Hollywood. Giữa hai quả bưởi đó là gần 3.000 dặm, hoàn toàn trống rỗng, không có vật thể nào khác, không có hành tinh và không có ngôi sao nào. Chỉ có 3.000 dặm chân không ảo giữa hai quả trái cây nhỏ. Thí nghiệm tưởng tượng này minh họa một cách sống động cấu trúc của nhánh thiên hà của chúng ta. Chúng ta không chỉ ở xa nhau, chúng ta bị cô lập bởi những khoảng cách đáng sợ ngoài sức tưởng tượng. Nếu bạn quyết định lái một chiếc ô tô từ mặt trời ở Washington để đến thăm Proxima ở Los Angeles với tốc độ 60 dặm một giờ, bạn sẽ mất hàng triệu năm trong thời gian thực để hoàn thành cuộc hành trình. Sự trống rỗng bao la giữa các vì sao này là vật thể vật lý lớn nhất trong thiên hà của chúng ta. Đó là môi trường giữa các vì sao. Trong khu vực này, mật độ vật chất giảm xuống, chỉ còn một nguyên tử hydro trên mỗi gen khối. Đây là một chân không sâu hơn bất cứ thứ gì chúng ta có thể tạo ra trong các phòng thí nghiệm tiên tiến nhất trên trái đất. Và trong chân không này, không có gì có thể bảo vệ hay che giấu chúng ta. Chỉ có cái lạnh buốt xương và những tia vũ trụ chết người không ngừng xuyên qua mọi thứ. Từ góc nhìn của một người quan sát giả định trong hệ Proxima Centauri, mặt trời của chúng ta sẽ không khác gì một ngôi sao mờ nhạt. Không có gì nổi bật giữa chòm sao Cassiopeia. Với những kính thiên văn tương tự như công nghệ hiện tại của chúng ta, họ sẽ hoàn toàn không thể nhìn thấy trái đất từ một khoảng cách xa như vậy. Đối với họ, chúng ta đơn giản là không tồn tại. Hành tinh yêu quý của chúng ta chỉ là một điểm ánh mờ nhạt, không thể nhìn thấy, hoàn toàn bị chìm trong ánh sáng rực rỡ của ngôi sao mẹ của nó. Ngay cả khi con người có thể vượt qua mọi rào cản kỹ thuật để di chuyển với tốc độ ánh sáng giới hạn, tốc độ tuyệt đối của vũ trụ, một chuyến đi thăm những người hàng xóm gần nhất của chúng ta vẫn sẽ tiêu tốn hơn 4 năm cuộc đời của bạn. Bất kỳ cuộc đối thoại nào với một nền văn minh giả định ở đó sẽ là vô nghĩa và xa hoa. Nếu bạn gửi một tin nhắn, xin chào, câu trả lời sớm nhất chỉ có thể đến sau 9 năm. Đây không còn là giao tiếp nữa. Thực chất, nó là một dạng khảo cổ học tín hiệu, khối cầu Hill vùng không gian nơi lực hấp dẫn của một ngôi sao chiếm ưu thế là ranh giới quyền lực cuối cùng của nó. Bước ra ngoài ranh giới đó là vùng đất không người của vũ trụ. Những sao chổi vô tình bị văng ra ngoài giới hạn này có thể lang thang một mình trong không gian giữa các vì sao hàng tỷ năm mà không bao giờ gặp một vật thể nào khác. Và theo một nghĩa nào đó, nền văn minh của loài người cũng ở trong một tình huống tương tự. Chúng ta giống như một hòn đảo nhỏ bé giữa một đại dương bao la, chỉ nhìn thấy nước ở mọi hướng mà không có bờ biển nào trong tầm mắt. Tuy nhiên, ngay cả sự cô lập lạnh lẽo này cũng sẽ bị lu mờ bởi những gì sắp diễn ra khi chúng ta phóng tầm mắt ra xa hơn nữa. Chúng ta đang chuẩn bị rời khỏi vùng lân cận của ngôi nhà sao nhỏ bé của mình và tiến vào không gian hoạt động thực sự của thiên hà. Tại đây, quy mô của vũ trụ sẽ có một bước nhảy vọt, biến năm ánh sáng, từng là một vực thẳm không thể vượt qua, thành một sai số làm tròn không đáng kể. Khoảnh khắc ống kính ảo của chúng ta di chuyển ra ngoài vùng lân cận của Proxima Centauri, bản chất của quy mô hoàn toàn thay đổi. Các ngôi sao riêng lẻ không còn là những điểm mốc đáng tin cậy nữa. Trong bóng tối băng giá này, những điểm sáng cô đơn bắt đầu hợp nhất thành một thứ gì đó lớn hơn nhiều những cấu trúc vĩ đại mà mắt người không thể nhận thức theo cách thông thường, nhưng lại hiện ra với sự rõ ràng hoàn hảo qua tầm nhìn điện tử của các đài quan sát trên quỹ đạo. Bây giờ, chúng ta không còn nói về những người hàng xóm riêng lẻ nữa. Chúng ta đang bắt đầu chiêm ngưỡng kiến trúc của toàn bộ khu vực thiên hà của chúng ta. Tại đây, trong các cụm máy chủ khổng lồ xử lý dữ liệu từ sứ mệnh Gaia, sự I am lặng chỉ bị phá vỡ bởi tiếng vô về đều đặn của các hệ thống làm mát. Đối với các nhà vật lý thiên văn chuyên về bản đồ học, tiếng vô về này là âm thanh của một vũ trụ đang chuyển động. Trên màn hình của họ không chỉ là những bản đồ sao tỉnh, mà là một lưới tọa độ 3 chiều sống động, dữ liệu vô giá từ kính viễn vọng không gian. Gaia đã biến sự hỗn loạn của bầu trời đêm thành một mô hình toán học chặt chẽ và hợp lý, và chính mô hình này đã ngay lập tức mang đến cho chúng ta một bất ngờ lớn trong khi phân tích sự phân bố của khí và bụi trong không gian. Các nhà bản đồ học đã phát hiện ra một sự bất thường kỳ lạ. Chúng ta từ lâu đã quen với ý nghĩ rằng vũ trụ được lấp đầy đồng đều bởi môi trường giữa các vì sao, nhưng dữ liệu thực tế lại chứng minh điều ngược lại. Hệ mặt trời của chúng ta không di chuyển qua một khu rừng khí và bụi rậm rạp, mà thực tế đang đi qua một khoảng không khổng lồ, gần như hoàn toàn trống rỗng. Các nhà thiên văn học gọi khu vực đặc biệt này là bong bóng địa phương. Đây là một khoang rỗng rộng lớn trong môi trường giữa các vì sao, trải dài khoảng 1.000 năm ánh sáng, với mật độ khí thấp hơn 10 lần so với mức trung bình của thiên hà. Bong bóng địa phương này không hình thành một cách tự nhiên. Thực chất, nó là một vết sẹo để lại từ quá khứ. Bằng chứng khoa học cho thấy, khoảng 14 triệu năm trước, một loạt các vụ nổ thảm khốc đã xảy ra ngay tại đây. Một chuỗi các siêu tân tinh đã bùng nổ, thiêu rụi và thổi bay mọi vật chất ra khỏi khu vực này, tạo ra một lớp vỏ khổng lồ, giãn nở chứa đầy khí nóng. Chúng ta hiện đang sống bên trong chính khoang rỗng vũ trụ này, với các bức tường được bao quanh bởi các vùng hình thành sao đang hoạt động, nơi các sóng xung kích từ những vụ nổ cố đại đó đã nén chặt tất cả vật chất lại với nhau. Hóa ra, sự an toàn và yên tĩnh của chúng ta ngày nay lại là kết quả của một thảm họa cố đại, khốc liệt. Nhưng ngay cả bên trong không gian thưa thớt này, khái niệm về mật độ cũng chỉ là tương đối. Hãy nhìn vào những con số liên tục chạy trên màn hình trong trung tâm điều khiển dữ liệu đó. Within a radius of just 100 parsecs from the sun, the Gaia telescope has catalogued over 300,000 stars. Imagine that. 300,000 giant thermonuclear reactors, each possessing terrifying power, capable of incinerating any seed of life that dares to venture too close. And this is just our most immediate backyard. An area so small, it's almost indistinguishable on the grand map of the Milky Way galaxy. If we continue to zoom the camera out even further, the boundaries of the local bubble will gradually dissolve, merging into a higher-level structure. We are now on the inner edge of the Orion Arm, a minor spur of the galaxy, wedged between the two colossal arms of Sagittarius and Perseus. From this macroscopic perspective, our Sun completely loses its individual identity. It becomes just one of countless specks of dust, silently revolving to the universe's singular gravitational rhythm. The scale of the Milky Way truly shatters all common human intuition. The diameter of the visible stellar disk is at least 100,000 light-years. To simply cross this region at the speed of light, you would need a period 20 times longer than the entire written history of human civilization. The light you see today from the other side of the galaxy actually left its source when our ancestors were just beginning to learn how to use the crudest stone tools. However, that visible stellar disk is just the tip of a colossal iceberg. The latest studies of the dark matter halo surrounding our galaxy have forced scientists to reconsider these boundaries. The gravitational influence of the Milky Way actually extends much farther, increasing its true diameter to nearly 20,000 light-years. We truly exist inside a gigantic body, where mass and size are determined by an invisible yet omnipresent material. Now, try to grasp the demographics of this stellar metropolis. By the most modest estimates, our galaxy contains between 100 billion and 400 billion stars. 400 billion. If each of those stars were just a tiny grain of sand, that would be enough to fill a football stadium with a layer of sand several meters deep. And somewhere in that vast expanse of sand, there is one specific grain that we call home. To an astrophysicist, these numbers are not just dry statistics. They are like a verdict of probability. Among these hundreds of billions of stars, based on precious data from the Kepler mission, about 1 in 5 stars likely possesses an Earth-like planet within the habitable zone. But the paradox of scale is that even with such astounding abundance, the average distance between potential civilizations could be thousands of light-years. We may not be alone in this universe, but we are hopelessly isolated by insurmountable distances. The image constructed on Gaia's servers shows the Milky Way as a flat disk with a brilliant bulge in the center. But that is just a static image in our minds. In reality, it is a chaotic vortex. New stars are constantly being born in dense nebulae. They live for millions or billions of years and then fade away, returning their gases to the eternal cycle of the galaxy. We are only seeing a snapshot of a grand process that has been unfolding for 13 billion years. When you look at the structure of the spiral arms, you'll notice they are not rigid structures. They are actually density waves moving through the galactic disk, similar to a traffic jam on an endless highway. Stars enter an arm, slow down, engage in complex gravitational interactions, and then quietly exit. Our Sun currently resides in a relatively quiet region between the main traffic flows, which has perhaps granted life on Earth a precious opportunity for long and peaceful development. But the deeper you look into the map, the more unsettling the picture becomes. Our cozy Orion Arm, or this safe, local bubble, it's all just the remote suburbs. If we shift our gaze toward the galactic coordinate center, the density of light begins to increase exponentially. There, at the very heart of the galaxy, the distance between stars drops to just a few light weeks or even light days, a place governed by entirely different physical laws, where the sky would never know darkness. We are approaching a region where gravity is no longer a weak force, but an absolutely dominant beast. The peaceful rotation of the suburbs is now replaced by a frenetic dance of matter spiraling around an invisible center. What for us is a serene night sky dotted with rare sparks would be, for an observer at the galactic core, a dazzling conflagration lit by millions of suns. We are leaving the quiet harbor and heading straight into the eye of a cosmic storm. All these hundreds of billions of stars, all this gas, dust, and dark matter are not orbiting by chance. They are obeying the will of a single master. At the very center of this great vortex, hidden behind dense clouds of dust, is a point of power that commands the orbit of every star, keeping the entire galaxy from flying apart. We are heading for Sagittarius A star, where the very fabric of space is twisted into a suffocating knot. You are now officially leaving the calm harbor of the Orion Arm. As you approach the central region of the galaxy, the concept of a night sky completely loses its original meaning. If Earth were located here, in the heart of the Milky Way, the neighboring stars would shine so brightly that you could comfortably read a book without any sunlight at any time of day. The distance between objects has shrunk from vast light years to mere light weeks, creating an environment of immense energy density and radiation. Here, in this region of extreme gravity, the very dance of the cosmos has completely changed. In the suburbs where we humans live, the motion of the stars seems static to us. Throughout the entire length of civilized history, the shapes of the constellations have barely changed. But at the galactic center, time and space seem compressed. The stars here do not drift lazily. They hurtle by at a frenetic pace, completing an orbit in just a few short human years, as if driven by an invisible whip from some dark power. Your attention is now drawn to a group of young, hot stars known as the stars. Their orbits seem paradoxical. They appear to be orbiting a completely empty space. There is no visible object at the focal point of their orbits. Yet, the gravitational force holding them is immense. One of these stars, named S2, at the closest point of its orbit, accelerates to a speed of over 7,000 kilometers per second, a terrifying velocity that nearly tears it apart by gravitational tidal forces. At this very point, which astronomers designate as Sagittarius A star, lies the gravitational anchor of our entire stellar system. It is a supermassive black hole. Its mass is 4.3 million times the mass of our Sunday. But listen to this. All of that enormous mass is packed into a volume with a radius smaller than the distance from Earth to Mercury. This is not simply a hole in space, but a dominant singularity that dictates the physics of the entire region. You cannot see its shadow itself, but what you see is its meal. Surrounding the event horizon is a swirling, incandescent accretion disk of gas and dust. As matter falls into this gravitational well, it is accelerated to nearly the speed of light, and extreme friction heats it to millions of degrees. This disk glows brilliantly in the X-ray spectrum, brighter than thousands of suns combined, emitting enormous jets of energy that pierce through the galactic plane. This mysterious object is the axis upon which our cosmic home rotates. The gravitational influence of Sagittarius A star extends for tens of thousands of light years, holding the spiral arms, gas clouds, and even dark matter together as a unified whole. Our Sun, despite being at a safe distance of 26,000 light years, must still obey the commands of this monster, silently orbiting it in a vast elliptical path. Here, we confront a timescale that the human brain struggles to process. One rotation of the solar system around the galactic center is called a galactic year. That 1 year lasts for about 230 million Earth years. In its 4.5 billion year history, our Sun has only completed about 20 such rotations. Think about this. The last time we were at this same point in our orbit, there were no flowers, birds, or any mammals on Earth. Our planet was still ruled by the early dinosaurs of the Triassic period, and the supercontinent Pangaea had only just begun to break apart. The entire grand journey of humanity, from wielding a stone axe to building a quantum computer, occupies only a tiny fraction of a second on the scale of a galactic year. This rotational cycle is relentless and absolutely precise, We are currently flying through space at 220 kilometers per second relative to the galactic center. But even at that dizzying speed, the universe appears to us to be completely still. That is the illusion of scale. We are merely tiny passengers on a colossal carousel, its mechanics governed by a supermassive object capable of swallowing entire stars. However, proximity to this blazing heart is also a death sentence. Astrophysical models show that life near the galactic center is nearly impossible. The density of supernova explosions there is so high that any atmosphere on an Earth-like planet would have been torn away by harsh radiation long before the simplest bacteria could have emerged. Our remoteness, our provincial location in this quiet Orion arm, is not an exile, but the very condition for our survival. Observing the dance of stars near the event horizon, you realize the fragility of stability. The black hole is currently relatively quiet. It seems to be dozing, only occasionally swallowing a rare gas cloud that passes by. But in the distant past, it was an extremely active quasar, and the echoes of those ancient eruptions still exist in the form of enormous Fermi bubbles, swelling above and below the galactic disk. We are fortunate to live in an era of tranquility. From here, from this absolute seat of gravitational power, the rest of the galaxy appears as a majestic, luminous disk. Hundreds of billions of stars, each with its own story, are all rotating in unison. But the Milky Way is not the entire universe. It is just our own little island. And if we look up, above the plane of this disk, beyond the murky dark matter halo, we will see that our island is not alone in that empty ocean. There, in the black abyss of intergalactic space, something immense is quietly approaching us on a scale that far surpasses the giant whirlpool we call home. The gravity of Sagittarius A star holds us together, but out there are forces to which even a supermassive black hole must yield. We stare into the darkness, and the darkness begins to take shape. The moment we silently leave the brilliant disk of the Milky Way and pass through the sparse dark matter halo that surrounds it, the familiar picture of the sky you've always known dissolves. Here, in the vast intergalactic void, concepts like up or down lose all meaning. The observer's eyes no longer find sparkling bands of diamond dust, but only absolute blackness. In that eternal night, like distant, lonely lighthouses, float the faint smudges of other islands of light. We have truly stepped outside our home, and the cold calculations of scientists reveal a sobering truth. Our home is, in fact, a fortress under siege. In this abyss, a theoretical cosmologist doesn't need to stretch his imagination too far. He just needs to quietly analyze the light spectrum. Looking at the faint smudge of the Andromeda galaxy, he notices a strange anomaly, a complete contradiction to the general picture of an ever-expanding universe. You see, most objects in the universe are moving away from us. Their light is shifted toward the red end of the spectrum, but this object is a rare exception. Its color lines are shifting dramatically toward the blue. This is a cosmic-scale alarm signal. A colossal structure is hurtling directly toward us. It is the Andromeda galaxy, also known as M31. The distance from here to there is 2.5 million light-years. To our tiny human perception, this number is truly abstract. But to the immense force of gravity, it is the distance of a head-on collision. The two gravitational giants, our galaxy and Andromeda, are now connected by the invisible chains of their mutual attraction. This pull is so strong that it overcomes the expansion of space itself. We are hurtling toward each other, and this process is utterly irreversible. Data from our telescopes allow us to calculate the speed of this approach with frightening precision: 110 kilometers per second. Just imagine, for every second that passes, the abyss between us shrinks by 110 kilometers. This is not just a random drift, but a direct, galactic-scale assault. While you have been listening to this sentence, the Andromeda Galaxy has silently moved several thousand kilometers closer to us. In his equations, the cosmologist sees not a romantic dance, but an inevitable catastrophe stretched out across time. The scale of this threat becomes clearer if we begin to assess our opponent. The Andromeda Galaxy is significantly larger than our Milky Way. Its structure contains about 1 trillion stars, more than double the number of all the stars in our home. If our galaxy appears as a massive disk, then Andromeda is like a colossal hammer held high above it. The gravitational potential energy of this system is so great that even now it has begun to distort the halo surrounding our galaxy, although visual contact will only occur after many long eons. Mathematical models show that the actual collision will happen in about 4.5 billion years. Ironically, this time frame almost perfectly coincides with the moment our beloved Sun will exhaust its hydrogen fuel and begin to swell into a red giant. For an observer in the distant future, if anyone still exists on Earth, the night sky will transform into a surreal and overwhelming canvas. The giant spiral of the Andromeda Galaxy will fill the entire sky, obscuring the familiar stars of the Milky Way. However, the term collision can be misleading. Here, the paradox of emptiness that we once recognized in our solar system comes into effect again. The stars are separated by such tremendous distances that the probability of two celestial bodies actually crashing into each other is almost zero. This will be a ghostly catastrophe. Imagine two fleets of hundreds of billions of stars silently passing through each other without physical impact. But their gravitational fields will create horrific chaos. Gravitational tidal forces will tear apart the elegant spiral arms of both galaxies. The structures we consider eternal, like our galactic disk or the Orion arm, will cease to exist. Simulations show that long tidal tails of millions of ejected stars will be scattered across intergalactic space. Our solar system, in this scenario, could very well be thrown into a distant fringe of the new structure, into a cold halo of space where we will be even more isolated than we are now. This massive merger process will take another 2 billion years after the first contact. At the heart of this cosmic storm will be the supermassive black holes. Our Sagittarius A star and the giant from the core of Andromeda will begin their own dance of death. They will orbit each other, spiraling closer and closer, emitting incredibly powerful gravitational waves until they merge completely into a single, monstrous object. The energy from this merger, for a brief moment, will completely outshine the light of all the stars in the newborn galaxy. The final result of this great catastrophe will be the birth of a completely new object. Astronomers have already given it a name: Milkomeda, a combination of Milky Way and Andromeda. It will no longer be a beautiful spiral galaxy with graceful arms, where new stars are actively born. Instead, it will be a giant elliptical galaxy, a shapeless, aging swarm of old red stars. All the gas needed for the birth of new celestial bodies will have been ejected into space or swallowed by the black holes. This will truly be a graveyard of stellar evolution. For theorists, this event is the clearest demonstration of how time dismantles all structure. The beauty of spiral galaxies turns out to be a fleeting phenomenon in the cosmic timeline. Chaos and gravity always tend to average things out, transforming complex and delicate shapes into simple ellipses. We are fortunate to live in a golden age of cosmology when we can still admire the magnificent structure of our home. In another 5 billion years, any intelligent species that might arise in Milkomeda will see only a hazy, formless fog surrounding them. But even when merged, the Milky Way and Andromeda are just a tiny part of something much, much greater. Together with the Triangulum Galaxy and about 50 other small satellite galaxies, we form what is called the Local Group. This is our neighborhood in the universe, a cluster of galaxies tightly bound by gravity. And if we continue to scale up even further, we will see that even this massive local group is just like a solitary speck of dust, quietly drifting toward a structure that is grander and more majestic still. Beyond the gravitational influence of the Andromeda Galaxy, true emptiness begins. There, in the deep night, distances are no longer measured in millions, but in hundreds of millions of light years. In that place, invisible forces are tearing apart the very fabric of space. We are leaving our cozy, albeit collision-bound, archipelago for the open ocean, where matter becomes an exceedingly rare and precious exception. Ahead of us is a journey through the void, a region where the existence of anything at all seems like a tiny statistical error. Here, the scale of the universe, once again, changes completely. We stop using trivial concepts like stars or galaxies and must begin to think in grander terms, like filaments, walls, and voids. And the first stop on this path will make you feel not just simple loneliness, but an existential horror at the sheer size of nothingness. We are officially leaving the gravitational harbor of the local group. The Milky Way and Andromeda, giants just moments ago, are now just faint specks of light fading behind us. Our instruments begin to record a sudden and sharp drop in the density of matter, and believe me, this is no instrument malfunction. We are entering the open ocean of intergalactic space, where the distance between objects is beyond all human comprehension. This is where the familiar rule of gravity ends, and the reign of absolute nothingness begins. Before us, an abyss is opening up that can terrify even the most seasoned cosmologists. This is the Botès Void, more commonly known by its haunting name, the Great Void. This isn't just a region of space lacking stars. This is a colossal, spherical hole in the very fabric of the universe. Looking into this deep darkness, I don't feel claustrophobia, but its complete opposite, agoraphobia. It's the primal fear of an endless, utterly empty space, where there is no up, no down, and not a single direction to hold on to. The diameter of this great anomaly is 330 million light years. To give you some perspective on this terrifying scale, let's return to the numbers we know. Light travels from the moon to your eyes in just 1 second. From our neighboring galaxy, Andromeda, it must travel for 2.5 million years. But for a single ray of light to cross this vast emptiness from one edge to the other, it would need 330 million years. That is an immense stretch of time, long enough for the dinosaurs to appear on Earth, reign, and then vanish from the planet completely. If we were to fly through this empty space on a spaceship at the speed of light for millions of years on end, the view outside your window would not change one bit. This is truly a perfect sensory deprivation chamber, the size of a significant fraction of the entire observable universe. Scientific estimates assert that within such a huge volume, there should be about 10,000 galaxies. Yet, astronomers have only detected fewer than 60 lonely galaxies here. It is here, in this deafening silence, that we truly realize the most fundamental structure of reality. We have become accustomed to viewing the universe as a dense collection of matter of stars, nebulae, and brilliant galactic disks. But observational data, gathered in recent decades, has completely inverted this picture. The Botès Void is not actually an anomaly or a rarity. On the contrary, it is the standard. Vast empty spaces like this actually make up about 80% of the volume of the entire observable universe. Our universe isn't like evenly scattered grains of sand. It's more like a colossal cosmic foam or a block of Swiss cheese full of holes. These giant empty bubbles are pressed tightly against each other, and all the matter familiar to us, galaxies, stars, planets, and even ourselves, is actually clustered together in the thin membranes and at the intersections where these giant bubbles meet. We are living in the narrow walls of a great cosmic honeycomb, always carrying a fear of looking into the vast empty cells where absolute vacuum reigns. However, even in this desert of nothingness, life exists. Inside the Botez void, rare galaxies drift unimaginably alone. The distances between them are so great that communication, or even simply observing one's neighbors, is nearly impossible. Let's try to analyze the position of an observer, someone unfortunate enough to be born on a planet in the center of such a reclusive galaxy. If our Milky Way were located at the very center of the Botez void, the history of human science would have undoubtedly followed a completely different script. Looking up at the night sky, ancient astronomers and later modern scientists would have seen only the stars of their own galaxy. Beyond its limits, even their most powerful telescopes would have encountered only an endless, empty blackness. According to astrophysicists' calculations, the nearest neighboring galaxies would be so far away that their light would be too faint to be detected by the instruments of the early 20th century. We would have known nothing about the existence of other galaxies until the 1960s, when sufficiently powerful radio telescopes and electronic light amplifiers began to appear. Until then, we humans would have firmly believed that the Milky Way was the one and only universe. Such terrible isolation would certainly have had fundamental consequences for physics. Without seeing other galaxies, we would never have discovered the famous Hubble's law. Living in the solitude of that void, we would never have had the chance to see the redshift, the crucial evidence that galaxies are constantly expanding away from each other. We also wouldn't have arrived at the Big Bang Theory at the same time that humanity did. Cosmology as a science would have been stunted in its development for centuries, and we would have been completely blind to the true scale of the universe. It's a truly terrifying thought. Our understanding of the laws of nature is directly dependent on our position in this cosmos. We were incredibly lucky to be born in a crowded population center, where the light from our galactic neighbors allows us to study and unravel the history of the world. The inhabitants of the Botez void have been deprived of this precious privilege. Their horizon of knowledge is limited by a vast darkness that even the most sophisticated instruments cannot penetrate. But what caused matter to avoid these regions? The answer lies hidden in the gravity of the early universe. Billions of years ago, regions with slightly higher densities of matter began to pull more matter toward themselves, quietly draining it from less dense areas. The voids are the result of this cosmic-scale cannibalism. They became empty because their original matter flowed toward the places where galactic clusters now burn brightly. Furthermore, actual observations have shown that these voids are still actively expanding. They act like growing bubbles in a pot of boiling water, silently pushing the galactic filaments further apart. It is from these dark abysses that a mysterious energy emanates, causing the entire universe to expand at an ever-increasing rate. This emptiness is not passive. It is an aggressive player, constantly claiming more and more living space for itself. And now, our imaginary vessel approaches the opposite edge of the Botez void. Ahead, in the darkness, faint lights begin to appear. These are not individual stars, but entire galaxy clusters forming the wall of a colossal void. We are approaching the boundary where emptiness, once again, gives way to great structures. Escaping this void is like returning to civilization after a long, aimless drift across the ocean. The density of galaxies begins to increase, and we start to discern not a chaotic swarm, but an orderly movement. These walls, which define the emptiness, are in fact powerful currents. We are officially entering the gravitational sphere of influence of a colossal structure, one that makes even a supercluster of galaxies look like a minor detail. As you leave the numbing silence of the Botez void, you'll notice a change that at first seems like an illusion. The scattered points of light that form the walls around the void no longer look like static islands. On the astrophysicist cartographer's screen, the data stream, once chaotic, has been replaced by an intimidating order. The galaxies are not merely suspended in space, they are truly flowing. It's reminiscent of a long-exposure photograph of a highway at night, where millions of headlights merge into single rivers of light, all rushing in one direction. For a cartographer working with a database of radial velocities, this picture reveals a fundamental truth about the structure of our home. Gravity on this grand scale doesn't act like a rigid bond, but more like a natural current. We have fallen into the influence of a giant gravitational basin. Just as rainwater on a vast continent flows toward a specific ocean, all the galaxies in our region, including the Milky Way and Andromeda, are sliding along the invisible slopes of space-time toward a single center. This crucial discovery, made by astronomer Brent Tully's team in 2014, forced humanity to completely redraw the map of the universe. We previously thought we belonged only to the Virgo supercluster, but now, by analyzing peculiar velocities, that is, the individual motions of galaxies, after subtracting the overall expansion of the universe, scientists have realized that the Virgo supercluster is just a small, peripheral branch of a much larger structure. That structure's name is Laniakea, which means immense heaven in Hawaiian. The scale of Laniakea is truly difficult to comprehend, even when you're looking at a three-dimensional model. This gravitational archipelago stretches across 520 million light-years. Within its tangled filaments, it contains more than 100,000 large galaxies and millions of billions of brilliant stars. If you could stand outside and observe Laniakea, you wouldn't see a sphere or a disk, but an incredibly complex root system or a neural network. There, nodes are connected by shining bridges of matter, constantly vibrating with energy and ethereal light. However, the most unsettling element on this map is the final destination. The velocity vectors of all 100,000 galaxies are pointing toward a region in the Norma constellation, obscured from the view of optical telescopes by the dense plane of our own Milky Way. There, in that hidden region, lies the gravitational heart of our supersystem, known as the Great Attractor. This is an anomalous region with a mass tens of thousands of trillions of times that of the Sun, greedily pulling all matter within a radius of hundreds of millions of light-years toward it. Our Milky Way is also hurtling toward the Great Attractor at a speed of 630 kilometers per second. Can you feel this dizzying velocity? The answer is no, because our entire local environment is moving in unison with us. It's just like being in freefall inside a giant elevator. When you're inside, the weightlessness provides a sense of calm, yet the instruments silently and dispassionately record this long slide into the abyss. We are, in fact, just a tiny drop in a great river of stars, having already traveled most of the way toward the universe's colossal waterfall. But this is where the greatest tragedy of modern cosmology emerges. Observing this majestic flow, astrophysicists have realized that we are participating in a race that humanity can never win. This competition is between the gravitational pull of the Great Attractor, trying to pull us in, and the dark energy that is constantly inflating space from the inside out. The calculations have yielded a disappointing result. The expansion of the universe is winning overwhelmingly. Despite our immense speed, we will never be able to reach the Great Attractor. The space between us and this gravitational center is being created much faster than we can traverse it. Laniakea is therefore not a structure that is forming, but one that is slowly dying in solitude. It has begun to disintegrate. The flows we see on the map now are, essentially, just the death mask of a cosmic giant. The gravitational bonds are gradually breaking, and in a few billion years, this beautiful river of galaxies will dry up completely, turning into a chain of isolated and distant lakes. However, understanding the structure of Laniakea has given us a precious key to deciphering the architecture of the entire universe. We are beginning to see that this universe is not chaotic. It is built upon the sophisticated principle of a cosmic web. Laniakea borders other superclusters like Perseus Pisces, Shapley, and Coma. Between them lie the vast voids we just crossed, and connecting them are thin, almost imperceptible filaments. It is within these threads that the secret to keeping galaxies from immediately dispersing into nothingness is hidden. You see, all the matter we can see, from stars and gas clouds to dust, does not actually have enough mass to create the great flows seen in Laniakea. If the universe only contained what we can see with the naked eye, the Great Attractor could never have accelerated us to 630 kilometers per second. Here, looking at the glowing filaments of the supercluster, you are truly facing a ghost. The framework of this grand structure is made of something invisible, yet it possesses a terrifyingly immense mass. When an astrophysicist creates a map, if they remove the layer of visible light from the model and leave only the gravitational potential, the picture changes completely. Laniakea appears not as a brilliant cluster of stars, but as a concentration of matter within a giant, invisible skeleton. We are slowly coming to the realization that our entire colorful, glowing reality is actually just a fragile, decorative layer stretched over a scaffold of dark matter. It is this mysterious substance that has determined the shape of the rivers of stars upon which we drift. The Great Attractor itself may just be the tip of the iceberg, part of an even more colossal structure called the Shapley supercluster, looming behind it. The Matryoshka doll of nested gravitational wells seems to extend infinitely, but the larger the structure, the more fragile it becomes against the relentless expansion of space. We are truly living in the era of collapse for the greatest empires in the universe. Take one last look at the map of Laniakea. It's a beautiful structure, resembling a feather from a mythical firebird. This is our true address in this vast universe. Not our tiny Earth, not the solar system, and not even the Milky Way. We are inhabitants of one of the branches of this great supercluster, and realizing this truth will completely change your perspective. Humanity's loneliness is no longer a local affair. It has become a collective loneliness. We are drifting together on a giant vessel with hundreds of thousands of other galaxies, slowly moving away from the remaining shores of the vast cosmos. But what exactly formed these miraculous filaments? Why did gravity arrange matter into a sophisticated web-like form, rather than an uneven fog? The answer lies not in the present, but hidden in our deep past, and it is buried in the very nature of the invisible substance that makes up 85% of the mass of the entire universe. To truly understand Laniakea, we must look deeply into the thing that is silently holding it together. To see the true architecture of Laniakea, a theoretical cosmologist at the Landau Institute did something that seemed counterintuitive. He turned off all the lights. Instantly, on his computer screen, billions of brilliant stars and galaxies vanished. The familiar map of the starry sky disappeared completely. But strangely, the screen did not go black. Right where the visible matter had just faded, the true master of the situation appeared. A colossal structure, silently vibrating. We cannot see it with our naked eyes, but we can clearly feel its gravitational breath in every movement of the celestial bodies. Before us, now, is a visualization from the Millennium Run project. This is one of the most detailed and ambitious simulations of the evolution of the entire universe. It is not a product of artistic imagination, but a rigorous mathematical calculation based on the most fundamental laws of physics. And this very calculation has revealed a stunning truth. Everything we hold dear, everything we can see and study, from stars and nebulae to planets and ourselves, actually makes up less than 5% of what constitutes this reality. We turn out to be just a tiny statistical anomaly. Through the eyes of the theorist, we no longer see individual objects, but instead the cosmic web, the grand framework of all creation. Enormous filaments stretch across space for billions of light years, connecting tightly at nodes of incredible matter density. It is here, at these gravitational intersections, that ordinary gas begins to accumulate. Galaxies ignite in a blaze of glory, and great superclusters of galaxies are formed. The universe that we can see with our naked eyes is, in fact, like a thin, glowing film stretched over a massive, invisible skeleton. The material that has woven this magnificent network is what physicists call dark matter. Note that this is not darkness in the sense of an absence of light, but an entirely different form of matter. It does not emit light particles, nor does it reflect or absorb them. It is completely inert to all electromagnetic interactions. The only language it uses to communicate with our world is the force of gravity. It is its enormous mass, accounting for about 27% of the total energy density of the universe, that silently keeps galaxies from flying apart. If we could view the Milky Way from the outside with a special kind of gravitational vision, we would no longer see a flat, bright disk. Instead, a giant spherical halo made of dark matter would appear before you. Our beloved galaxy would look like a tiny pearl nestled in the center of a vast and invisible shell. Without this hidden mass, the rotational speed of stars at the galaxy's edge would be absurd. The centrifugal force would have simply torn the beautiful spiral arms apart, and our sun would have been flung into the coldness of intergalactic space long ago. Try to look at the scale of these filaments in the simulation. The thickness of each strand can be up to tens of millions of light years. These are the largest structures that have ever existed in nature. The vast empty spaces between them are the voids we mentioned earlier. They are not just meaningless voids, but areas where dark matter has swept everything clean to build its solid walls. This structure looks very much like a sponge. The empty bubbles grow larger and larger, compressing matter into thin boundaries. The cosmologist sees in these structures an eerie symmetry. The geometry of the cosmic web is strangely similar, mathematically, to the structure of spongy bone tissue, or even the network of neurons inside the brains of mammals. The self-organizing principles of matter on the scale of billions of light years and at the micro level of neurons turn out to be astonishingly alike. Our universe appears like a giant brain, but it is cold and moves very slowly. There, instead of electrical impulses traveling along nerve axons, there are flows of galaxies silently drifting along axons made of dark matter. We are accustomed to thinking of ourselves as the main characters on the stage of creation. But the standard model of cosmology, based on precious data from the cosmic background radiation, has put humanity back in its humble place. The ordinary matter that makes us up, like protons, neutrons, or electrons, is in fact just tiny foam on the crest of a great wave. We exist only because the gravitational wells of dark matter allowed clouds of gas to accumulate and compress to the state of nuclear fusion. On the simulation screen, you can see this network constantly evolving over time. In the early universe, it was loose and uniform. But after billions of years of gravitational instability, it has transformed into a rigid framework. The gravity of dark matter acts like a great architect who first builds an invisible scaffolding system, and only then allows the workers, the hydrogen and helium atoms, to fill it with the bricks of brilliant star systems. However, you should know that even this colossal skeleton is not eternal. Theorists have noticed in their charts the influence of another force, one we have not yet mentioned: dark energy. It is working in opposition to gravity, constantly trying to pull these cosmic filaments farther apart. At present, the cosmic web still appears stable, but in the distant future, the accelerating expansion of the universe could break even these seemingly indestructible bonds, leaving each node in absolute solitude. Realizing this terrifying scale completely changes how we perceive reality. When you look up at the night sky, you are actually seeing only a very small part of the whole picture. You are only seeing an exception to the rule. The real rule states, the universe is a cold, invisible, and untouchable network, cast across the deepest abyss. We live in rare oases of light, entangled in this mysterious web, and our world is actually just a byproduct of the shadow play of that invisible mass. The most incredible thing in this picture is that we cannot directly interact with the very foundation of our own home. Dark matter can pass through the earth, through your body, and through the most solid laboratory walls. Right now, billions of dark matter particles are passing through us every second without touching a single atom in your genetic code. To them, we are just faint ghosts, and to us, they are gravity. These two worlds coexist in the same space, but can almost never truly touch. This model explains why the universe has the shape it does today. Why does Laniakea flow? Why is the Andromeda galaxy hurtling towards us? All of these grand movements are happening along those invisible threads. But if we truly want to understand where this network came from, we need to look at its history through time, not just its structure in space. We need to find the light that began its journey when this network did not yet exist. The theorist closes the simulation. Mathematics has explained the structure, but to confirm its validity, we need authentic evidence from the distant past. We need a witness who saw with their own eyes how this foundation was laid. And fortunately, such a witness does exist. It has flown to us through the darkness for 13.8 billion years, gradually losing energy, redshifting, and stretching out. Yet it has always preserved the memory of the first moments of creation. Let's leave the theorist's office and return to the telescope control center. Where theory stops is precisely where the archaeology of observational cosmology begins to speak. The operator of the James Webb Telescope is preparing to look at a place where the very fabric of space-time once had a very different appearance. We are beginning a journey to the very edge of observable history to witness the childhood of this giant network. The silence at the control center of the Space Telescope Science Institute is only on the surface. Here, in the city of Baltimore, there are no roaring turbines or screaming rocket engines, but the tension in the air is thicker than during a Soyuz launch. The mission operator sits before the screen, doing exactly what the theorist said: cosmic archaeology. He is not just looking at the stars, he is meticulously sifting through particles of light that began their journey when Earth didn't even exist in any of creation's plans. A new, deep field image is loading onto the screen. To an untrained eye, it might just look like a scattering of jewels on black velvet, with thousands of points of light, shimmering spirals, and ellipses. But the James Webb operator sees a strict temporal order in this brilliant chaos. He understands that the fainter and redder a speck of light is, the deeper we are diving into the vast well of time. This image isn't a conventional map of space. This is a historical slice of the universe, leading us billions of years into the past. The central paradox you face here is this: the farther you look, the younger the universe appears to you. Because the speed of light is finite, this has inadvertently turned any telescope into a great time machine. You can never see objects in their true current state. You see the moon with a 1-second delay and the sun from 8 minutes ago. But here, on the screens of this control center, that delay stretches into eons. We are witnessing infant galaxies that, in our present time, have likely long since grown old or even vanished completely. The operator focuses on a barely perceptible reddish smudge. This is absolutely not an equipment malfunction or dust on the lens. This is light that has persevered on its journey to us for 13.5 billion years. To capture it, engineers had to painstakingly create a colossal mirror, coated with the thinnest possible layer of gold, and send it to a Lagrange point, far from the thermal interference of Earth. But why is it so red? The answer lies in the very fabric of space. While this light was tirelessly traveling to us, the space between us and the source was constantly expanding. This stretched the light waves themselves, much like you would stretch a spring. The short ultraviolet waves, originally emitted by young, hot stars, have transformed into longer infrared wavelengths after their billion-year journey. Astronomers call this phenomenon redshift. This is precisely why the Hubble telescope couldn't see these objects before. They had truly receded deep into the infrared spectrum and become invisible to conventional optical lenses. Analysis of the light spectrum confirms our hypothesis. Before us is an ancient object, similar to the JADES GSZ 130 galaxies. The dry catalog numbers conceal an astonishing truth. This galaxy existed only 300 to 400 million years after the Big Bang. On a human timescale, this is like looking at a photograph of a 3-day-old infant who has now become a 100-year-old man. In that distant past, there was no carbon for life in the universe, no planets, and not even the familiar-shaped galaxies we see today. You are seeing the age of primordial chaos. This was the time when mists of hydrogen were just beginning to coalesce into the first clumps of matter under the gravitational pull of dark matter. The stars inside this galaxy are nothing like our sun either. They were giants, living fast and dying spectacularly, great forges where the first heavy elements began to be hammered out. The operator isn't just seeing a distant light. He is actually witnessing the start of a grand mechanism that, billions of years later, would create the very iron flowing in your blood. But here, your reason stumbles upon an intuitive trap. If the light has traveled to us for 13.5 billion years, does that mean the galaxy is currently 13.5 billion light-years away? The answer is no. In an ever-expanding universe, the travel time of light does not correspond to the actual distance. While the photons were diligently flying toward us, the space behind them inflated tremendously, greatly increasing the actual distance. It's like running up an escalator that's going down. The photon races toward us at the speed of light, the universe's ultimate speed limit, but the spatial path beneath it is constantly being stretched out. Mathematical models have revealed an astonishing fact. The galaxy the operator is seeing on the screen is, physically, now located a distance of over 30 billion light-years away from us. We are only witnessing its ghost, an afterimage left behind at the starting line. Furthermore, the object that emitted this light at this very moment very likely no longer exists in its original form. It may have merged with other galaxies, transformed into a giant star cluster, or even been completely swallowed by a supermassive black hole. We are truly looking at a cosmic illusion. The reality behind that tiny red dot is forever obscured by a dense wall of both time and distance. As the operator shifts the image, hundreds of similar dots of light appear before you. These are the first knots of the great cosmic web. You are seeing the framework of the cosmic building at the very moment its foundation was being laid. It was here, in that deep antiquity, that the smallest fluctuations in the density of matter began to determine the fate of future clusters and superclusters of galaxies, including our own Laniakea supercluster. But this glimpse into the past has an extremely harsh limit. The James Webb Telescope can see very far, but its vision is by no means infinite. Hidden behind the first galaxies we just witnessed are the cosmic dark ages. That was a long period when stars did not yet exist, and the entire universe was filled with opaque hydrogen gas. And further back still, there exists a wall that no telescope, no matter how advanced, can penetrate. That is the particle horizon, the final edge of the observable universe. The particle horizon is like a giant sphere, marking the limit of the volume of space from which light has had time to travel to us over the past 13.8 billion years. Everything beyond this boundary, for us, might as well not exist. simply because the light from there has not yet had enough time to reach Earth. We are trapped at the center of an observational sphere, a sphere whose radius, though constantly increasing every day, will never allow us to see the full, grand picture of creation. It is crucial that you recognize the scale of this isolation. The galaxies whose light we are capturing now are in fact extreme objects located at the very edge of our sight. Due to the constant expansion of space, the light emitted from them has been stretched to the extreme, completely transforming into radio waves. We see them appear red, faint, and tiny, although in reality they could be vast and majestic supercities of stars. The very expansion of the universe has stolen away all the fine details, leaving us with only faint silhouettes of the past. The operator quietly saves the final lines of data. For science, this is a priceless archive. But for human consciousness, it is a profound lesson in humility. We are standing before a boundary we cannot see beyond. However, physics whispers to us that out there, beyond that horizon, space does not end. There will be no physical wall with the words, "The end of the universe," inscribed on it. Out there, similar galaxies, similar stars, and the exact same laws of physics are surely continuing on. From this, we arrive at a staggering conclusion. The observable universe is actually just a tiny bubble with a diameter of about 93 billion light-years. This is a colossal volume of space, but it's also just like a small area illuminated by a flashlight within an endless dark forest. What we see is never the entire universe. It is only the small fraction that has had time to send us a message of light. And the most concerning part of this discovery is not that we see too little. What is truly alarming is that we are gradually losing contact, even with what we have already seen. Space is expanding, and it is doing so with increasing acceleration. The galaxies at the edge of our vision today are not just receding, they are literally fleeing. And one day in the future, they will cross a boundary from which their light can never reach us again. Even if it had all of eternity to travel. The operator turns off the screen, but the calculations quietly continue. We have seen the past. We have assessed the distance of the present. But now, we must look to the future. We must look to where the expansion of space becomes so fast that it shatters the very concept of proximity. We are approaching the boundary where light begins to lose the hopeless race against space. That is the Hubble sphere. As the telescope operator completed the analysis of the redshift, a picture unfolded before the theoretical cosmologist that was breathtaking, not for its beauty, but for its unshakable finality. You see, the light from distant galaxies wasn't shifting to red on its own. This was the Doppler effect, taken to its absolute extreme. The galaxies weren't just floating in empty space, they were actively flying away from each other. And the farther we look, the faster this recession becomes. Here, in the silence of the office, the mathematical formulas on the board suddenly transformed into a death sentence for reality. We are living in a universe that is trying to tear itself apart. To understand the scale of this tragedy, you must accept a counterintuitive truth. Space itself is not an empty, static stage, but a dynamic, evolving medium. Imagine an infinite rubber sheet being stretched in all directions. The galaxies are like tiny dots drawn on that fabric. They may be stationary relative to the rubber sheet, but the distance between them is constantly increasing because the very space between them is expanding. This is how Hubble's law operates, and this expansion has a specific speed. The Hubble constant, refined by modern missions, now sits at about 70 kilometers per second per megaparsec of space. This number may not sound like much, but the key phrase here is per megaparsec. This is a terrifyingly cumulative effect. If two galaxies are 1 megaparsec apart, the space between them expands at 70 kilometers per second. But if the distance is 10 megaparsecs, the recession speed is already 700, and if it's 100 megaparsecs, that number becomes 7,000. The cosmologist saw an unavoidable threshold in the equations. There exists a critical distance at which the expansion speed of space is exactly equal to the speed of light. This boundary is the Hubble sphere. This isn't a physical wall, but a very special kind of event horizon. Everything beyond this sphere is moving away from us faster than 299,792,458 meters per second. This gives rise to a key paradox that often confuses many. The great Albert Einstein once stated that nothing can travel times through time-space faster than light. And that is absolutely true. But that prohibition does not apply to space itself. The fabric of the universe has no speed limit. It can expand faster than a particle of light. And that is exactly what is happening right now, beyond the boundary of the Hubble sphere. Let's try to see this through the eyes of a photon emitted from a galaxy just outside that boundary. This photon is traveling toward us at the maximum speed the universe allows. It desperately tries to bridge the distance to Earth, but the space beneath it is expanding faster than it can travel. It's like a swimmer trying to go against a powerful current. If the speed of the water is greater than the speed of the swimmer, no matter how hard he tries, the shore will only get farther away. For an observer on Earth, this means a permanent loss of causal contact. The light from objects beyond the Hubble sphere is trying to reach us, but for every kilometer it travels, 2 new kilometers of empty space are created. That light will never reach the mirrors of the James Webb Telescope. It is permanently locked in expanding space, swept away from us at superluminal speeds. We call this the cosmological horizon. The statistics that theorists derive from modern models are truly staggering in their hopelessness. Calculations show that about 97% of the galaxies we can theoretically observe today are, in fact, already beyond our reach. We see their light as it appears now, but that is light that was emitted billions of years ago when they were closer to us. We are seeing only ghosts, but physically, in present space, they have already crossed the point of no return. This means that if humanity could right now build a ship that travels at the speed of light, the absolute physical limit, we would still never be able to catch up to that 97% of the universe. We're already too late. The vast majority of the universe has been permanently cut off from us by this merciless expansion. We are trapped in a local pocket of reality, while the rest of the cosmos drifts away into nothingness. The situation is made even worse by a crucial discovery confirmed by 21st century data. The expansion of the universe is not just continuing, it's accelerating. Dark energy is acting like a foot, pressing down on the universe's accelerator. The Hubble sphere is therefore not a fixed boundary. It is shrinking, severing more and more regions of space from our grasp. Every second that passes, thousands of star systems silently cross this threshold and disappear from our lives forever. For a cosmologist, this is like the gradual fading of the last opportunities. The galaxies that are on the edge of our vision today will, in a few billion years, fall beyond the event horizon. Their light will be stretched until its wavelength exceeds the size of the entire visible universe. They will vanish completely into darkness, leaving humanity in a terrifying solitude. In the distant future, about 100 billion years from now, any astronomer living in the Milky Way will see a completely empty universe. All other galaxies will have escaped beyond the event horizon, and the superclusters will have dissolved. Only our local group of galaxies, the Milky Way and Andromeda, merged into a single giant galaxy, will remain, surrounded by an impenetrable, eternal night. Future civilizations might not even know that anything else ever existed in the vast cosmos. This realization has completely changed the meaning of the observable universe. What we see is not a map of present reality, but a photograph of an inaccessible past. We see a galaxy as it was 13 billion years ago, but at this very moment, it could be up to 40 billion light years away from us, and moving away at twice the speed of light. All connection has been completely severed. We often think of the universe as a frontier waiting to be explored, but the laws of physics coldly tell us, you can look, but you can never touch. Gravity is only strong enough to hold together the local structures of galaxy clusters. Everything not bound together strongly enough will be torn apart by the relentless expansion of space. Our world is essentially an archipelago of islands, drifting further and further apart in an ever-widening ocean. Einstein's and Friedman's equations describe this geometry with a cold precision, but even they cannot answer the question, where is the universe expanding times into asterisk? What lies there beyond the event horizon, where the recession speed has surpassed even the speed of light? If 97% of the visible universe is inaccessible, what is the true size of the invisible part? We are approaching the boundary where astrophysics ends and pure theoretical abstraction begins to reign. The fact that we cannot catch up to the light does not mean that nothing exists beyond the event horizon. Relativity asserts that space there is exactly like it is here, the same laws of physics, the same atoms, and perhaps even similar stars. They are just permanently isolated from us. These are vast swathes of reality that exist, evolve, and die completely unaware of our existence, just as we are of theirs. However, even this picture, with its receding galaxies and event horizons, only describes what happened times after times, the Big Bang. So what started this grand process? Why did the universe begin to expand? And why is it so vast and uniform? To answer this question, we need to go beyond the standard Hubble model. We need a theory that can explain the very birth of space. Physicists call it inflation. It was a moment at the very earliest time when the universe expanded not just fast, but instantaneously. If the theory of inflation is correct, then our entire visible bubble, 93 billion light-years in diameter, is in fact an insignificant grain of sand on the surface of something unimaginably greater. Are we ready to take a step from the merely large to the infinite? We have officially crossed the boundary of the observable and touched the event horizon of our understanding. But you know, it's the very laws of logic that often whisper to us that wall only really exists in our limited human perception, not in objective physical reality. The question that relentlessly haunts the minds of cosmologists isn't what is out there, but rather how much is out there. The answer that modern physics provides might just leave you staggered. Even if you have a mind prepared for the magnificent, it transforms our entire observable sphere with its colossal 93 billion light-year diameter into nothing more than a tiny statistical anomaly. To truly grasp that real scale, we need to look deep into the geometry of space. Precious data, gathered from the WMAP and Planck satellites, have revealed a startling truth. Our universe is astonishingly flat. In this space, parallel lines will never, ever intersect, and the sum of the angles in a triangle is always exactly 180 degrees. To you, this might sound like just a standard mathematical theorem we learned in school, but to a physicist, it's a highly suspicious anomaly. Think about it. In a chaotic and violent explosion that created matter, space should have been warped and tangled. The fact that we see it so smooth is evidence of a grand trick of perspective by nature itself. Let's recall the classic paradox of the tiny ant on a balloon. If the balloon were the size of a soccer ball, the ant would clearly feel the curve of the surface beneath its feet. It would understand that it lives on a sphere. But if we were to inflate that balloon to the size of the Earth, an ant standing in the middle of a vast desert would be utterly convinced that its world is a perfect flat plane. This is simply because its horizon is too narrow to perceive that great curvature. We, tiny humans, are that ant, And the fact that we don't see the universe's curve means only one thing. The sphere we're resting on is truly, extraordinarily immense. This is where the theory of inflation emerges to decode this mystery. This concept, developed in the early 80s, completely rewrote the script for the first moments of the universe's life. It posits that before the hot Big Bang, there was a period of cold, exponential expansion. A special energy field, called the inflaton field, took over the vacuum and began to stretch it with ferocious power. Space wasn't just expanding, it was constantly doubling, then doubling again. And this process repeated hundreds of times. The numbers describing this process are truly beyond normal human comprehension, but we must state them to appreciate its grandeur. This entire inflationary period lasted for an unimaginably brief moment, about 10 to the negative 35th seconds. That's a decimal point followed by 34 zeros. But in that fleeting instant, the universe increased its size by a factor of at least 10 to the 26th power. To help you feel that scale, it's equivalent to a tiny proton in just a fraction of a moment, swelling to the size of our entire Milky Way galaxy. You might want to object, arguing, how could something like that happen if nothing can move faster than light? But this is actually a rather common misconception. The theory of relativity only limits the speed of objects moving within space. It places absolutely no limit on space itself. The very fabric of reality can be stretched at any speed. During that brilliant inflationary epoch, points that were once in close contact were flung apart at speeds many times greater than the speed of light. It was this tremendous stretching that created the vast abyss we see today. It is thanks to this colossal stretching that the mysterious flatness of our world can be explained. Try to imagine a crumpled up piece of paper. If you start stretching it out in all directions, increasing its area to the size of an entire continent, then all the original wrinkles and unevenness will be smoothed out. Inflation took the initial quantum chaos and stretched it so powerfully that, from our tiny, local perspective, the geometry of space has become indistinguishable from a perfect Euclidean plane. So, what is the true size of the universe? If this inflationary model is correct, then the entire observable universe, the very bubble we have all been studying for so long, is in fact nothing more than an insignificant grain of sand. The total volume of the universe created by inflation, to use an analogy, would be like the entire vast Sahara Desert. We are spending our whole lives just to map a single grain of sand, completely unaware of the existence of millions of other great dunes surrounding us. Take a moment to reflect on this analogy. Each neighboring grain of sand in that cosmic Sahara Desert is actually a volume of space equivalent to our entire observable world. Over there, they have their own galaxies, their own stars, and perhaps even their own civilizations, but they are all forever cut off from us. The space between our grain of sand and theirs is expanding too fast, so fast that light will never be able to cross this distance to connect the two worlds. These are not just distant worlds. They are realities that are completely causally isolated. They physically exist, but to us, it is as if they are forever non-existent. However, the comparison to a desert is perhaps still too modest. Some solutions to the inflation equations suggest that this expansion may have lasted even a bit longer, or occurred even more intensely. In that case, the true size of the universe could exceed the size we can observe by a factor of 10 to the 10th power. We are dealing with numbers against which the number of atoms in all visible stars seems like an absolute zero. At such magnificent scales, the word size gradually loses its conventional physical meaning and becomes a pure mathematical abstraction. There is another ironclad piece of evidence for this enormous scale, and that is the universe's temperature. If you look at the leftover radiation on the left side of the sky, and then look to the right side, you will see their temperatures are identical to a precision of a percentage point. Yet, These points are billions of light years apart. They've never had a chance to come into contact during the entire existence of the universe, and thermal energy couldn't have transferred from one point to another to equalize. In classical physics, this is utterly impossible. Scientists call this the horizon problem. Inflation solves this mystery instantly. Before the maximal expansion began, all matter was packed into a volume smaller than an atomic nucleus. At that moment, the temperature had time to reach a state of equilibrium. And then the inflationary explosion broke this connection, throwing the thermally balanced regions to opposite ends of the distant universe. The uniformity we see today is the lingering imprint of that ancient proximity, an imprint that has been stretched across millions and millions of kilometers. This leads us to a somewhat unsettling conclusion about our place. We aren't just living in a tiny world, we are actually living in a quiet pocket of space. The theory of eternal inflation suggests that expansion is the natural state of reality. Our Big Bang wasn't the beginning of everything, but merely the moment when inflation in this local region stopped and the vacuum energy began to transform into hot matter. We are like a single drop of water that has cooled within a relentlessly boiling ocean. Outside of our stable bubble, the process of inflation is likely still happening violently right at this moment. While we are busy looking through our telescopes, somewhere far away, space is ceaselessly creating new volumes, giving birth to new universes every fraction of a second. We exist in a multiverse that resembles a giant foam, where each bubble is a separate universe with its own physical constants, completely isolated from the rest by a region of vacuum that never stops expanding. The data on the curvature of space remains our most reliable anchor in this vast sea of theory. Measurements from the Planck telescope have confirmed the flatness of the universe with an accuracy of up to 0.4%. This is the gold standard of modern cosmology. This reality leaves us with no other choice. We are forced to admit that the radius of curvature of the universe must be at least hundreds of times larger than the Hubble radius. The unobservable part of reality now mathematically holds absolute dominance over the part we can see. Don't try to picture it as a lone sphere floating in darkness. Instead, imagine an endless, edgeless fabric. No matter how far you fly, you will only encounter more and more galaxies, stretching on into infinity. And because the expansion is accelerating, this endless fabric is constantly creating new regions of space between objects. We're not just lost in a desolate desert. That very desert is constantly creating new miles of sand right under our feet. A scale this grand creates an unavoidable statistical paradox. If space is infinite, or at least vast enough, then the number of ways to assemble matter within it is finite. There are only so many ways to arrange atoms into a structure like a human being or a specific planet. If you have an infinite number of tries, that is, an infinite volume of space, then repetition becomes an inevitability. We have officially reached the final psychological frontier of astronomy. First, we realized the smallness of the Earth compared to the Sun, and then the galaxy. And now, inflation tells us that even our entire observable universe is nothing more than a cramped cage. We are trapped in a local volume, mistaking it for the entire grand cosmos. And somewhere out there, in the endless expanses of mathematical probability, a story exactly like this one is likely being told by another version of you. A theorist at the Research Institute quietly puts down his chalk and looks at the equation he has just written on the board. To him, these dry symbols don't just describe some distant universe. They describe a terrifying structure of reality that we are all trapped inside. The inflation model doesn't just stretch space, it does something even more radical. It probably never completely stops. According to the theory of eternal inflation, our Big Bang was not, in fact, a singular event, but more like a tiny clap in an infinite series of great explosions. Try to visualize this process through the lens of geometry. The space between universes is expanding so fast that light can never cross this abyss to connect them. We are living in what is called a Hubble bubble, a small, cozy pocket of space where inflation has slowed down and allowed stars to form. But outside the boundary of our bubble is a violently churning ocean of energy, ceaselessly giving birth to new universes with every passing moment. This is absolutely not science fiction, but a direct consequence drawn from the equations of quantum mechanics and general relativity. Within that infinite foam, a mathematical certainty arises that would make any cosmologist feel dizzy. It is the ergodic principle. This principle states that if you have an infinite amount of space and an infinite amount of time, then any event with a non-zero probability of occurring is guaranteed to happen, and not just once, but an infinite number of times. Here, in the absolute silence of the research office, the physicist suddenly realizes that the word unique has lost all its meaning. In infinity, there is never room for a single copy of anything. Let's translate this into the driest of numbers. Our observable world is made up of a finite number of particles. The laws of quantum mechanics dictate that these particles can only be organized in a certain limited number of configurations. The laws of quantum mechanics whisper to us that these particles can only be organized in a certain limited number of configurations. Physicists have performed enormous calculations to find this number. It is 10 to the power of 10 to the power of 122. You know, this number is so large, it's impossible for the ordinary mind to imagine. It far exceeds the total number of atoms in the entire visible universe we've ever known. But strangely, it is still a finite number. This is the ultimate limit of diversity in creation. And now, try to make a comparison between this finite number of variations and the infinite space of the multiverse. Once you have crossed a large enough distance in the void, the combinations of fundamental particles will begin to repeat themselves. It works just like shuffling a deck of cards. If you deal cards forever, the hands will inevitably start to repeat. This is an unavoidable mathematical certainty. The equations assert that somewhere out there, beyond the distant horizon, there exists an exact copy of our galaxy, our solar system, and of the very quiet room where you are sitting right now. According to the patchwork universe model, your complete quantum duplicate is at a distance that can be written as 10 to the power of 10 to the power of 28 meters. This distance is truly a terrifying number, lying far beyond our event horizon, but it is absolutely not infinite. That doppelganger of yours, at this very moment, is also reading or listening to this same text, experiencing the same range of emotions, and possessing the exact same memories as you. The only difference might be that a minute ago, he made a different choice than you did. The theorist sees in this not just soulless duplication, but a magical branching of reality. In some nearby patch of the universe, an asteroid happened to miss the Earth 66 million years ago, and a brilliant civilization was built by the descendants of the dinosaurs. In another patch, history took a dark turn when Germany won the Second World War, and in a third patch, the seeds of life perhaps never sprouted at all. Everything that can physically happen is, in fact, happening somewhere out there at this very moment. Our human history is just one of countless branches of probability, but the structure of the multiverse may be much more complex than that. We've discussed copies of our world, but string theory also posits the existence of other types of bubble universes. In these distant and strange domains, the fundamental physical constants can be completely different. The electrons there might be heavier, and the force of gravity could be much weaker. In such strange universes, atoms cannot even form, and they remain forever as desolate, dark, and soulless wastelands filled with cold radiation. This explains the so-called fine-tuning of our universe. We were once astonished to find that the mass of a proton, or the charge of an electron, were so perfectly suited for life to arise? The multiverse's answer is both cynical and staggeringly simple. We won the grand prize in the cosmic lottery. Simply because all the tickets were bought, there are countless dead universes with the wrong physical laws, and in them, there is no one to ask the questions. We exist in the one place where our presence is possible. For observers like us, this concept fundamentally changes our perception of ourselves. You are used to seeing yourself as a unique individual, the center of your personal consciousness. But on the scale of the multiverse, you are not a solo artist, but rather part of a grand chorus. Your life is not a single, straight line, but an endless tree of variations being realized simultaneously in space. Your every smallest decision, every what-if question you've ever asked, is creating a new branch of reality in a giant fractal structure of existence. However, contacting or reaching these worlds is utterly impossible. The spatial distance between these bubbles is expanding faster than the speed of light, creating permanent, insurmountable barriers. We are forever isolated within our own version of reality. Even if humans possessed a starship capable of traveling at the speed of light, we could never reach the edge of our own bubble, let alone enter a neighboring world. We are truly prisoners of our own probability. The theorist's gaze quietly returns to the blackboard full of symbols. The formulas describe a structure like soap foam, where each bubble is a separate universe, existing and moving according to its own clock. Some universes are being born at this very second, while others have quietly collapsed into nothingness. Our universe, to which we have always assigned such great importance, is in fact just a normal fluctuation in a perpetually simmering vacuum, a place with no beginning and no end. This vision of the world is somewhat frightening in its cold indifference. It strips humanity of the last vestiges of its arrogance about being special. We are not the center, we are not the first, and we are certainly not the only ones. We are just a repeating pattern within an infinite material kaleidoscope. But it is this very infinity that guarantees the immortality of the seed of life itself. If it can blossom here, it will surely be present everywhere. This universe is not only vast, it is utterly and completely full. We have journeyed from the familiar orbit of Earth to the farthest frontiers of the multiverse, and at every step, its scale has left us in awe. But the most wondrous paradox is this. This entire colossal structure is actually determined by the laws of the very smallest things. The shapes of galaxies and the distribution of universes within that inflationary foam were decided at a level smaller than an atom. To truly understand the macrocosm, we must take one final leap, the most dizzying leap of all, to turn our gaze inward. Our reality is like an Ouroboros, the ancient image of a serpent biting its own tail. The properties of the endless space out there are determined by the seething of quantum foam, at distances where even the concept of space begins to lose its meaning. We now stand at the threshold of the Planck length, the most fundamental pixel of the universe, a thing than which nothing can be smaller. It is there, in that microscopic abyss, that the ultimate source code controlling all of infinity lies hidden. We are accustomed to seeking infinity by looking up at the dark sky, peppered with galaxies. But to close this circle of knowledge and comprehend the true architecture of reality, we must do something that seems impossible. Turn around and look in the opposite direction, deep inside matter itself. The connection between the giant superclusters and the invisible microworld is far stronger than our intuition suggests, because the vast universe we just observed is, in fact, just a magnified projection of what is happening at the subatomic level. Our ordinary human vision stops at the thickness of a strand of hair. A light microscope allows us to see a living cell. An electron microscope reveals the ghostly shadows of atoms, but we must go further, beyond all barriers of conventional perception, through the electron clouds, through the vast, empty spaces inside an atom, we approach the nucleus. Here, at the scale of a quadrillionth of a meter, protons and neutrons reign, but even they are not the final foundation. Deep within them, in a powerful gluon field, quarks, the most fundamental bundles of energy, are constantly vibrating. However, even quarks are still giants compared to what lies at the very bottom of reality. If you continue to zoom in, falling deeper into the abyss between particles, we will confront the fundamental resolution limit of the universe itself. Modern physics imposes an incredibly strict condition. Space cannot be divided infinitely. Reality actually has a graininess. It has its own minimum pixel, and nothing can exist that is smaller than that. We have reached the Planck length. This number is unimaginably small, 1.6 times 10 to the power of -35 meters. To give you a sense of this tiny scale, compare it to an atom. To an atom, the Planck length is so small it's almost non-existent. Just as an atom is tiny compared to the entire observable universe, with its diameter of 93 billion light-years. The chasm separating us from the foundation of reality is almost greater than the chasm separating us from the edge of the entire cosmos. At this ultra-microscopic level, the familiar geometry we've known for so long completely ceases to function. There is no longer the calm, flat space and continuous time that we always imagined. According to quantum gravity theories, at the Planck scale, the fabric of reality becomes a seething, turbulent quantum foam. Here, space is constantly being torn apart, twisted into microscopic wormholes, and then immediately vanishing into nothingness. Concepts like up, down, before, or after completely lose all physical meaning within this topological chaos. Many modern theorists, including proponents of string theory, believe that this is where extra dimensions lie hidden. 6 or 7 hidden spatial axes may be curled up into tiny loops at this very scale. What we perceive as fundamental particles, like electrons or quarks, may in fact be just the vibrations of one-dimensional strings, resonating within the multidimensional space of this Planck foam. But the most astonishing thing in this picture is not the complexity of the microworld, but its profound influence on the macroscopic world. Recall the theory of inflation. In the first moments after the Big Bang, space expanded so rapidly that microscopic quantum fluctuations, the very ripples of this Planck foam, were stretched to the colossal size of galaxies. The large-scale structure of the universe, the vast cosmic web we saw earlier, is actually a photograph of the quantum world. Magnified trillions upon trillions of times, reality is truly an eternal circle. We cannot understand the birth of galaxies without understanding quantum fields, nor can we explain the vacuum state without accounting for the gravity of the entire universe. We stand in the middle of this ladder of scale, caught between two great abysses, the infinitely large and the infinitely small. And paradoxically, those two abysses perfectly mirror one another. We have taken this universe apart, piece by tiny piece, from the Laniakea supercluster down to the Planck pixels. We have seen that matter is just a rare dusting, time is relative, and space is a dynamic stage, capable of ceaseless expansion and vibration. Now, with all the pieces of this grand cosmic puzzle in hand, we have only one final step left. We need to put them together to find the answer to the ultimate question. What will be the final fate of this great structure? We have broken reality down into its parts, from the seething quantum foam where space is born, to the giant superclusters where it slowly dies in the process of expansion. But this grand structure has one more dimension that we have not yet mentioned: time. If we now allow the simulation to run forward, fast-forwarding through the eons, like rapidly scrolling frames, we will see the majestic architecture of the cosmos, once thought to be eternal, begin its inexorable collapse under the weight of its own physical laws. According to the most modern cosmological models, we are currently living in the early phase of the stelliferous era, but the reserves of hydrogen gas are not infinite. In about 100 trillion years, a length of time so vast the human brain cannot comprehend it, the process of star formation in the universe will cease completely. The last red dwarf stars will finally burn out and quietly fade away. The night sky we have always known will become permanently black and cold. The galaxies, once shining brightly with billions of lights, will turn into vast graveyards of cold, stellar remnants, drifting silently in the frozen emptiness. Gravity, the great architect of the universe for billions of years, will ultimately become the gravedigger of its own creation. All remaining matter will be flung into intergalactic space or swallowed whole by black holes. The era of black holes will officially begin. The very same gravitational monsters we once observed with awe at the center of the Milky Way will become the sole and final source of energy in a dying universe. But even their dominion over space is by no means eternal. Quantum mechanics has ordained for them an inescapable end. As the genius Stephen Hawking once pointed out, black holes are not completely black. They constantly emit tiny particles and gradually lose mass. This process is extremely slow. For a supermassive black hole to finally evaporate completely, it would take an amount of time described by the number 1 Google years. That is, a 1 followed by 100 zeros. On the scale of that dark eternity, the entire history of humanity, from the first fire lit to the last starship built, will occupy less than a tiny moment of Planck time. In the end, heat death awaits us all. Entropy will reach its maximum. The temperature of all space will drop to near absolute zero. All physical processes will come to a complete halt, because energy can no longer flow from a hot place to a cold one. Even the very concept of time will lose its meaning, because there will no longer be any events occurring within the universe by which one could measure it. All that will remain is an eternal, silent, and utterly mute darkness. This picture might serve as a source of your existential dread. It confirms a cold thesis. This universe was not created for us, and it seems completely indifferent to our fate. However, you should know that within this cold truth lies a paradoxical reason for optimism. Take another look at the timeline. From the infinite darkness of the past to the infinite emptiness of the future, here we are, in a narrow window of time that astrophysicists call the golden era of the universe. This is our single greatest privilege. We exist at a rare moment when the universe is still filled with brilliant energy, when the stars still light our path, and when the accelerating expansion has not yet swept neighboring galaxies beyond our event horizon. We often complain about the prison of light speed and the loneliness across millions of kilometers without understanding the most important thing: the very ability to see the universe, to study its grand structure, and to recognize our own humble place within it is in fact a glorious victory in a cosmic lottery with nearly impossible odds. Our journey began with the realization of our own pathetic smallness against the vast scale of the cosmos. We saw ourselves as nothing more than a layer of atoms on a tiny speck of dust, orbiting a mediocre star. But now, at the end of this road, that equation has completely changed. We are the means by which the universe becomes aware of itself. The atoms that make up your body, forged in the nuclear furnaces of dying stars, have miraculously assembled to create the most complex biological machine, an entity capable of deducing the laws of quantum gravity and gazing beyond the edge of the observable world. The scale of human intellect has fully compensated for the immense scale of space. Yes, physically, we are trapped within our solar system, but our minds are completely free to wander from the minuscule Planck length to the distant frontiers of the multiverse. If you, like me, feel a sacred awe before this vast abyss and wish to continue the journey of seeking meaning amidst the chaos of matter, then stay with us. Your attention and burning thirst for knowledge are the precious energy that allows us to continue this project, to light candles of wisdom in the darkness of ignorance. In the end, we are not merely a random fluctuation in the vacuum. We are the only observers capable of fully appreciating the beauty of this magnificent, fading world. And as long as there is at least one mind to look up at the sky and ask questions, this vast and cold universe will never exist in vain. We are its meaning,